In this video, we'll go over a couple more examples that have to do with quadrilaterals and the properties that we learned about them. I just found this graphic. I know it includes more than what we had talked about, but this is the quadrilateral family. I had talked about how, we have a parallelogram and then we have all these other things that are also a parallelogram. So a trapezoid, one of the definitions of a trapezoid is that it has at least one parallel side. So a parallelogram has two sets of parallel sides. So, a parallelogram is also a trapezoid. We have quadrilateral, so then we have trapezoid, which is at least one parallel side. Then we branch off into kite, which a kite is perpendicular diagonals. And so a rhombus is actually a kite because it does have perpendicular diagonals. It's also a parallelogram because of the two parallel sides. We branch off into rectangle, which talked about having two parallel sides and four right angles. And then we have square in the middle as, being a parallelogram, a rhombus, and a rectangle because it has all those properties. So you don't really have to exactly copy all this down. Just wanted to show you this family and how, it kind of branches off into the different types that we talked about. Okay, so one of the types of problems we're going to do is coordinate proofs. We already did these with triangles. We proved that we had isosceles triangles, equilateral or scalene, and that was when we had a triangle on a coordinate plane where we actually graph the points. And so we're going to need to show what type of quadrilateral we have now, similar to what we were doing with triangles. So you do need to copy this part down. This is what you have to show in order to prove that we have a parallelogram and so forth on the coordinate plane. So to prove a parallelogram, we have to show that opposite sides are parallel, and the way we do that is with slope. Remember, parallel lines have the same slope. We'll also show that opposite sides are congruent, and we'll show that with the distance formula. So we'll get the same answer from for the sides that are across from each other. And that will be enough to prove that we have a parallelogram. So to prove we have a rectangle, we're going to need to show that opposite sides are parallel. That's with slope. We're going to need to show that opposite sides are congruent. That's with the distance formula. And we'll also need to show that we have one right angle. And so if we have a right angle, that's because two sides are perpendicular, and so we're going to show that they have opposite reciprocal slopes. I'm going to go over an example where we use this. Then we have proving a rhombus. All we need to show for a rhombus is that we have four congruent sides, and we do this through the distance formula, and all the other properties will follow if we have four congruent sides. And finally, we have proving a square. To prove a square, we need to show that we have four congruent sides with the distance formula, which will prove that it's a rhombus. And then after that, if we show that we have one right angle using the opposite reciprocal slopes of two of the sides, then that will be enough to show that it's a square. So on a square and a rectangle, all we have to do is show one right angle, and because of the properties of a parallelogram, the rest of them will be right angles. So we're going to do an example of that next. Make sure you had paused and written down all the ways that we're going to have to prove these quadrilaterals. Okay, so we're going to prove that quadrilateral STUB is a square. So how we're going to start that off is by graphing the points. So here's STUB, and yeah, to me it looks like a square, but I need to know for sure. So if we think back to the previous page, we said we need to show that we have four congruent sides. We also need to show that we have one right angle, either at S, T, U, or B, anywhere, any one of those four. So to show we have four congruent sides, we're going to be using the distance formula. Remember, I had gone over how we can simplify the distance formula. Instead of plugging in the points, we can just look at the run, and we could look at the rise, and we can bypass like plugging in x2, x1, y2, and y1. So I'm going to show how to do it that way. So if I'm finding ST, so ST, I count the rise, and from count the run from S to T. I go 1, 2, 3, 4, and then I go up 2. So I'm going to plug in 4, which was my run. I'm going to square it, and I'm going to add it to 2 squared, which is my rise. And then I can work that out. 4 squared is 16. 2 squared is 4, and we get the square root of 20. And I'm not even going to do anything with it because, you know, if I get the square root of 20 for my other answers, without simplifying, I'll be able to tell that all 4 are the same. So next I'm going to do TU. Feel free to pause at any moment if you need to copy down the work. So TU, looking at the run from T to U, I run 2 and I rise 4. I'm actually going down 4, but I don't even have to worry about the negatives. When we square it, it'll all become positive in the end. So I had a run of 2, so 2 squared, plus a rise of 4, so 4 squared, and again, that's 16 plus 4, which is giving me the square root of 20. I have 2 more sides to go, so then I need to do BU. BU, the run is 4, the rise is 2. So again, I have 4 squared plus 2 squared, and look, I'm getting the same numbers every time. I know that's going to give me square root of 20. Finally, I have SB, and I see the run from S to B is 2, and the rise is also 4. So I'm going to plug in my 2 squared plus 4 squared, and again, I know that's going to give me square root of 20. So I do have 4 congruent sides that I just showed here. Now, last thing that I have to show is that I have a right angle somewhere. So I'm just going to pick right here. I think this is where my right angle is. Now, that doesn't prove it by just putting the box there. Remember, I have to look at the slopes of the 2 sides that are forming that right angle. So that would be the slope of ST, and that would also be the slope of SB. So I'm going to look at those slopes right now. And ST, slope is rise over run, remember? So the slope of ST is a rise of 2 and a run of 4. So 2 over 4 is my slope for ST. Now my slope for SB, it is going down, so I need to make sure that I have a negative slope for this one. So negative. My rise, I'm going down 4, and I'm running 2. So as you can see here, these are opposite reciprocals. One is positive, one is negative. I have 2 over 4, and then it flipped to 4 over 2. So that was what I needed to prove a square. I just showed that ST and SB are perpendicular. They form a right angle, and I've also shown that all 4 sides are congruent. Okay, so now we're going to do a problem with some algebra. So that was a coordinate proof. Okay, so then this is an algebra one. So what I've done first is I drew a diagram of a rectangle. I have ABCD as a rectangle, and so I wanted to draw that out and then label these things that they're giving me. So they gave me that BCD is 5x plus 14y, so BCD, 5x plus 14y. I'm given that AB is 2x minus 5. AB is 2x minus 5, and then CD is 3y minus 12, 3y minus 12. So I also went ahead and marked that these two opposite sides, which I'm given, are congruent, and I marked that I have a right angle here. So because we have two variables in this problem, we're going to have to set up two different equations. And that's what I've done here. I have two equations to solve for two variables. So I set 2x minus y equal to 3y minus 12 because I know those two sides are congruent. And my second equation, I set 5x plus 14y equal to 90 because I know this angle right here is a 90-degree angle on a rectangle. So what I do from there is this is a system, and I have to use a system method, and I'm going to use substitution. So I first take the first equation and I'm solving for one of the variables. I decided to solve for x. So I'm adding 5 to both sides. I'm trying to get x by itself. I get 2x equals 3y minus 7 because negative 12 plus 5 is negative 7. I divide both sides by 2. So I cancel my 2's, I just get x, and then 3 divided by 2 is 1.5y, negative 7 divided by 2 is negative 3.5. So I've solved for one variable. Now I'm going to take that and plug it in to the second equation. So I literally took the whole second equation and I just replaced x with that with the value over here. And so now my whole equation is just y, and I'm going to solve for y now. So I'm going to have to start by distributing my 5 to inside the parentheses. When I do that, 5 times 1.5, I get 7.5, and then 5 times negative 3.5 is negative 17.5. And then the rest of the equation I just carried down. Then I go and combine my y's. 7.5y and 14y gives me 21.5y, and the rest of the equation I copy down. Minus 17.5 equals 90. I'm going to continue solving by adding 17.5 to both sides, and I get 21.5y equals 107.5, and then when I divide both sides by 21.5, I get y equals 5. Now I'm almost done. I still have to get x, so the last thing that I do is plug this value back into one of the equations. I'm going to go with this one right here, and that will give me the value for x. So I plug it in instead of y. Now I put the value I know, which is 5. I get 1.5 times 5 minus 3.5. When I work that out, I get 7.5 minus 3.5, and x is 4. So I have two answers, x and y. In order to do that, I had to have two equations, and I solved by substitution. Feel free to rewind this problem if you need to hear it again, and jot down any questions that you have, and I will answer them in class. See you then.